We are Group 2 and we'll be doing an analysis and recommending design improvements to can openers.
Can openers are used in both commercial and personal household settings. The can opener is placed on top of a metal food can and squeezed to cut through the top of the can with the blade. The crank is then turned as the gears spin around the can to cut open and remove the lid. The annual production volume is estimated at 50,000 units.
The primary customer for this product would be any typical household kitchen users. The average household would own one can opener. The secondary customer would be any household kitchen user that may require a can opener with adaptive features. This customer may be elderly or disabled and may not possess adequate hand strength to use a standard manual can opener.
This is our bill of materials with the exploded view of the can opener CAD.
This slide shows the FAST diagram for this product. The FAST diagram identifies the important product functions and how they are realized by other subfunctions. The task function is open can. The task function is broken down into the primary basic functions pierce lid and cut lid, and the primary supporting functions assure dependability, assure convenience, enhance product, and please senses. These primary functions are further broken down into basic functions and supporting functions.
An assembly sequence when we start with the upper frame and follow that with the gear pin, blade gear, spacer, cutting blade, pin clip, then the lower frame, crank handle, twist wing pin, handle clip, blade gear, can rotating gear wheel, main pivot pin, and finally the handle grips.
In assembly sequence 2, we start with the subassembly of the lower frame, subassembly of the crank handle and twist wing pin, and subassembly of the handle clip, blade gear, and can rotating gear wheel. Then insert the subassembly of the upper frame and subassembly of the gear pin, blade gear, spacer, cutting blade, and pin clip. Next, insert the main pivot pin, then finally the handle grip. After comparing the two sequences, assembly sequence 2 is more favorable due to the ease of testing subassemblies for their functions and assembling subassemblies in parallel.
This slide shows the function component mapping matrix, which illustrates which product functions are realized by which components. The rows represent the components of the can opener, and the columns represent the terminal subfunctions from the FAST diagram. As can be seen from the matrix, each component has at least one function, and each function requires at least one, but typically multiple components.
This is our bill of materials. The material cost was determined by looking at similar parts made through the same processes on custompartnet.com, assuming 50,000 units were produced. The total cost for the manual assembly process was determined to be less expensive than if the same process was automated, so the manual process was chosen. The assembly cost was determined by using the average hourly rate of assembly line workers in the United States, which is about $15.61. The total cost to produce one unit was then calculated to be $5.90. As shown in the previous slide, all the components of this product are relatively low cost. The low functional importance parts include the gear pin, twist wing pin, spacer, and pin clip. The only part that is able to be consolidated of these is the spacer, which would be combined with the blade gear, as they do not need to move independently of one another and are made of the same material. The gear pin, twist wing pin, and the pin clip need to allow different components to move independently, so those are not able to be consolidated. Additionally, the handle clip will be combined with the lower frame to reduce the number of parts in the assembly.
Based on the FAST diagram, the modules of our assembly are the handle grips and the crank handle, which modify the applied and maintained force for the different customer groups.
Here we can see the primary variant with standard length and size handles and a standard crank. Here we can see the adaptive variant. The handle length is twice as long to allow for more leverage while opening the can. It also features a mechanism that will hold the can opener shut while using to help reduce fatigue. The adaptive variant also features a new crank handle. This helps to increase leverage while turning the crank and can help eliminate problems for users with wrist issues.
The original assembly sequence shown on this slide illustrates a single path for one specific assembly. The modified assembly sequence introduces differentiation when the crank is assembled and delayed differentiation at the end of the assembly for the handle grips. Because of the assembly sequence, this is the optimized path for introducing variants into the sequence and will allow the product to be marketed to both customer groups.